Hello, AP Stats scholars. Welcome here to the Unit 9 Big Ideas video, which I will call everything you need to know about one sample significance tests. Um, One thing that is really good to kind of look at on the front page of your AP Statistics formula sheet is just the general formula for the standardized test statistic. So this is the statistic minus the parameter over the standard error. So the parameter, just remember that parameter is kind of the null value in this case. Okay, so we have symbols here for the statistics and the parameters again. Um, so we have our proportion problems for the 9.2. And then we have the sample mean problems for the 9.3. And the choose is just a lot like what we've done before. Outline what the parameter is. And we're still going to be using z-scores and t-scores as well. So z-score for proportion problems and then t-score for mean problems. One thing that you also want to kind of lay out carefully is your null hypothesis. So in the case of a p-value, it's going to be p equals blank. And then the alternative hypothesis will be p is either less than, not equals to, or greater than blank. And you just have to kind of read the problem and see whether it's a less than problem, a not equals to, or a greater than problem. And we use p and not p hat because we're looking at true proportion. And that's what we're trying to kind of make statements about. All right, and then for the means, we just kind of replace, for mean problems, the null hypothesis would be mu equals blank. So we're testing a value, a null value for what the average would be. And then the alternative would be that mu is either going to be less than, not equals to, or greater than blank. So when we do that, that will be successful in the choosing and specifying the test. All right, now we go to our second C. So this determines and conditions. This is exactly like in Unit 8 and in Unit 7 as well for sampling distribution problems. So the terms and conditions remain exactly the same. So we're checking the random, we're checking the 10%. One thing that people do get mixed up on still sometimes is when to use large count versus central limit theorem. So you use large counts. So you want successes and failures to be greater than or equal to 10 in the proportion problems. And then in the mean problems, you want to kind of see, is that population distribution, is that normal? Or if it's not normal, is that sample size going to be at least 30, to where we can use that central limit theorem. Again, we have AP Statistics formula sheet and where to kind of get the stuff. So you'll have all that you need for your computations, where you can get the parameters and you can get the mean of the sampling distribution and the standard deviation of the sampling distribution. What I kind of put here is where we got these from the formula sheet. So if we want to find the mean of the sampling distribution, we use the null value for both the mean and proportion problems. So just keep that in mind. You're going to use the null value, not the sample value. One thing that we do kind of change a little bit in the standard deviation of the sampling distribution is that it's really going to be Sx over square root of n for the standard deviation. The general formula for the test statistic is going to be your statistic. So that's kind of the value that you got when you tested, minus the parameter over your standard deviation. At the null value. So what that kind of looks like into practice is that if we want to do the z-score formula for the proportions, that's going to be p hat minus p over your standard deviation. So it's just going to be p times 1 minus p over n square rooted. That's going to be your z-score. And then for the general specific formula for the test statistic in the mean problems, you're going to do the sample mean minus the mean of a sampling distribution, which is the null value that you're testing. And you're going to divide that by Sx over square root of n. And just remember that you want to be having your picture as well. So if you're doing a z-score, it is a normal distribution. So you're just going to use n, and you're going to do your muse of p hat and your standard deviation of p hat. And you're going to be using a t-distribution picture with the degrees of freedom. So you just do t parentheses df to kind of specify your t-distribution, and then you do the appropriate shading from a picture when you're doing that t-test. One last thing that you want to do is actually get a p-value. So how you find a p-value is for the proportion problems, you're going to look up your z-score. And you're going to kind of pay attention to whether you're shading above or below. If you are shading above, you do 1 minus the value, p-value on your table. And if you're shading below, the z-score gives you your p-value. Now for the t distribution, there's two ways that you can do this. So you can do the t-test on the calculator, or you could use table B with the appropriate degree of freedom. And always remember, for the two-sided tests, this is a little reminder, multiply your probability by 2. And this is kind of like the example we used in class. You know, you go to a pediatrician's office for your future kid, and you might ask the pediatrician, is my kid growing normally or not? Well, there's two ways that kids cannot grow normally. Either they're not growing enough or they're growing way too much. And those two abnormal outcomes cause the p-value to multiply by 2. All right, last but not least, we got to celebrate all the computation, and we have to do the fourth C, which is conclude. And this is kind of a good way to conclude. So you can say because whatever p-value you got is greater than or less than the significance level. So you just kind of compare how does that value that you got compared to like that 5% or that 1%. We either reject. So remember, if you get a low p-value, you are more likely to reject the null hypothesis. Or we fail to reject the null hypothesis. And then we can kind of say that there is or is not convincing evidence that blank. One thing that will kind of be advertising here as well, you might notice on the mastery that we might have some questions about comparing confidence intervals with significance tests. So significance tests, they can't really give us values against the null hypothesis, but confidence intervals can kind of give us a range of values for where the true p is at or where the true mean is at. Versus the significance tests can only tell us whether the null hypothesis is feasible or not. So that's where we're kind of comparing the confidence intervals and the significance tests.